So let's talk about it sort of from the American perspective for a second. So, it's one thing when we talk about climate change and we talk about how it changes resources in the Middle East, because obviously there's a real scarcity of water, whether the climate is changing or not, although it obviously is. But, we can use a couple examples from the United States. So first, let's talk about Hurricane Sandy and sort of how did climate change come to play on that? And then I want to talk about Florida and Miami specifically, which people are saying may not even be around in 20 years. Don't
tell that to Rick Scott, though. No. As far as he's concerned, climate change is a dirty word. It's remarkable. Hurricane Sandy is really a great opportunity to talk about the various ways that climate change may be impacting extreme weather events, very damaging extreme weather events. So the one thing we know for certain is that global sea level rise caused the storm surge associated with Sandy at Battery Park in New York, for example, to be at least a foot above what it otherwise would have been. A 13-foot storm surge rather than a 12-foot storm surge. And if you do the calculation, just that one extra foot gives you 25 square miles of additional coastal flooding in New York, along the Jersey coast. Industry groups totaled up the estimated damage, something like $6 to $7 billion of additional damage just due to that 1 foot.
Yeah, wait, okay. Can you unpack that a little bit? Because I think people maybe don't understand that 1 foot, it doesn't sound like a lot, but actually because water will just go wherever it's supposed to go, it basically can create mass chaos.
Exactly, because our coastlines are generally pretty flat, and so if you add 1 foot of water to the ocean surface, that allows the water to extend in potentially many miles. Just 1 foot of water can mean many miles inland of additional flooding. And so what happened here was that 1 extra foot of sea level rise, which we know is due to human-caused warming of the planet, that 1 extra foot meant 25 additional square miles of flooding, of flooded area, and billions of dollars of additional damage. And that's only looking at the one aspect of Sandy where there's an ironclad tie-in to climate change. There's a credible argument that can be made that the intensity of Sandy was greater because of the greater warmth of the ocean and more energy to drive that storm. There's an argument that can be made that the unusual trajectory that Sandy took, and this is where the science gets really interesting. So most storms curve out to sea, but Sandy instead decided to make a beeline for the Jersey coast in New York City, a very unusual westward track that it took towards the East Coast. And that track was part of a larger scale pattern of circulation of the atmosphere. It had to do with the unusual jet stream pattern that prevailed at that time. And there's now quite a bit of work that has suggested that particular unusual jet stream pattern may be favored by the loss of sea ice in the Arctic. And the loss of sea ice in the Arctic is, of course, associated with the warming of the planet, the warming of the Arctic, which is human-caused. Right. So even there, even in the unusual trajectory that it took, there may be a tie-in. And I could go on and on.
Yeah, how do you guys decide in a case like that where it sounds like you're speculating somewhat, but you're trying to tie all this together? What would be the piece of evidence that you could then say, okay, well, it actually does have to do with the Arctic ice? Like, what's the actual thing that makes it, all right, now we got fact?
Yeah, it's a great question. It gets us into a really interesting area of the science. In fact, there was a report that came out last week from the National Academy of Sciences, which was about climate change and extreme weather events. And how are the characteristics of extreme weather tied to climate change? And there's an emerging science to address precisely the sorts of questions that you ask here. And it's sort of like a whodunit. It's sort of like a court case.
Right.
It's sort of like a detective, like a murder mystery, where you have some event that happened, and you want to know, did climate change, make that event substantially more likely, enough more likely that we can basically say climate change impacted that event in some way, the magnitude of that event. And what they do, what we do, climate scientists, is we'll take a climate model, and we can run that climate model under two different conditions. In the first case, under pre-industrial atmospheric CO2 conditions, i.e. an atmosphere that hadn't yet been impacted by human-caused greenhouse gas increases. And you run the model, and you see how often that sort of event happens in that model. Then you run the model again with elevated levels of CO2 in the atmosphere, corresponding to the carbon that we've put into the atmosphere. And you can see how much of a difference that made in terms of the frequency and the magnitude of that kind of event. And the scientific community is really making a lot of progress in bringing those sorts of tools to addressing questions like, the California drought. What was the role of climate change in the California drought, in the heavy flooding events in Texas last year, in an event like Hurricane Sandy? So we are now able to start to provide some meaningful answers to those questions.
All right, so with all that in mind, let's talk about Florida for a second, because as you said, they have a Republican governor, Rick Scott. He's not big on anything that you have laid out here for the past half hour. A lot of people are saying that Miami, I've been to Miami many times, I like Miami, great beach, that Miami literally could be underwater in 20 years. Is that true?
Yeah, and it's ironic, right? Because if anybody is on the front lines of climate change right now, it's Florida, southern Florida, Miami Beach. And I have family who spend half the year down in Boca Raton in that same area, and I can tell you that there's this event. It's a seasonal event. You get these very high tides called king tides, and they've always been. It's a natural, phenomenon. But what happens now is when those king tides arrive, the streets of Miami get flooded. That didn't used to happen. And each time it arrives now, the flooding increases in extent where Fort Lauderdale is now getting flooded, or inland parts of Fort Lauderdale. And that's the way that we're going to see the impacts of climate change. It isn't just going to be some slow, creeping sort of inundation of the oceans. What it means is that the extreme events are going to become more extreme. And a flooding event that we might have been able to deal with, that the seawalls that they've built might have been able to keep out, will no longer be adequate. And we will get recurrent flooding. Eventually the flooding becomes so recurrent that there's nothing you can do but retreat, literally retreat.
Yeah, I mean, that's an incredibly depressing thought. So in the case of Miami, they've got some of these seawalls, and we know that New Orleans had the levees, and the levees failed, and we can talk about that a little bit too. But if you look at this from the idea of 20 years from now, that's the number I keep hearing, that it could be something like 20 years. That's a very short amount of time, all things considered. So is there literally anything, with all the info that you have, is there anything that can be done for Miami at this point?
Yeah, I mean, we typically talk about two things when we talk about dealing with climate change. We talk about mitigation, which is to say, let's prevent as much additional climate change as we can. We're already committed to a certain amount of warming of the planet from the carbon we've already burned. It's already in the atmosphere, and the Earth is still catching up to the increases in CO2 from a decade ago. So there's a certain amount of committed further warming, a certain amount of committed additional sea level rise. We think that, at least at this point, we could adapt to the changes that are already locked in, that are already baked in. What we can't adapt to is if we continue with business as usual, burning of fossil fuels for several more decades, we're going to be beyond the danger zone. We're going to be at a point where we can no longer meaningfully adapt to many of the changes, whether it's building seawalls and levees to protect our coasts, or literally slowly migrating inland with our major cities. That can be done over a time scale of hundreds of years.
Right.
When you ask, if you try to relocate New York City or Miami Beach, let alone any of the other major coastal cities of the world, in 10 years, 20 years, that may be beyond our ability, beyond our capacity. So to a large extent, it's about slowing the warming as much as we can and preventing as much additional climate change as we can, in the hope that we are still within our adaptive capacity. The changes that are locked in, we can probably deal with. It's going to require a lot of investment in new infrastructure. It's going to be, a much larger effort than the Apollo project.
Right, and this is sort of where politics is always certainly behind the science, but even behind the people, because I think if the real populace heard the types of things in a more mainstream way that you're saying, they would say, yeah, we need to deal with this now. But of course, you have a governor who's always worried about re-election, so doesn't want to put money into a long-term project because he's going to be long gone by the time that happens. But do you think we're getting to the point where humans will not be able to live in a place that's below sea level? So New Orleans, for example, which is, as you know, of course, below sea level. So the sea is here, New Orleans is here. We create these levees to artificially allow ourselves to live in these places. Are we just getting to a point where that just simply won't be possible?
Yes, and you were talking about the politicians who continue to deny that anything's happening, and it always reminds me of the famous Upton Sinclair quote: "It's hard to get a man to understand something when his salary depends on not understanding it."
Yeah, well, that's politics 101 right there, right?
So so some of that is willful ignorance, especially given just how decisive the scientific evidence now is. The person on the street now gets it. The latest Gallup polling shows, I think it's something like 70% of the population that now recognizes that climate is changing and that there's a human role in that. And that 30% that doesn't, well, you always have the 25 to 30% fringe in almost any issue that you poll. So that's
right, 70 cents. That's pretty good, 70%.
That's remarkable. 70% of the public, even despite the ongoing disinformation campaign funded by fossil fuel interests and the Koch brothers, which has really been aimed at hampering the efforts of the scientific community to inform the public. Basically, our efforts have faced this stiff headwind of industry-funded misinformation and disinformation. But despite that, because people are seeing it with their own two eyes, people are seeing the impacts of climate change directly in their own lives, and it makes it very hard to deny something's happening when people see it themselves. So I think we are at that point. With Katrina and New Orleans, it's a great example of a worst-case scenario. The largest impacts of climate change are going to be on the most vulnerable. Okay, and there are various reasons for that. There are a lot of very large populations in low-lying coastal regions of the world, like Bangladesh. Mm-hmm. Food production. The ironic twist here is that we could potentially see slight increases in agricultural productivity here in parts of the U.S. because of warmer winters and longer growing seasons, but in the tropics, where they're already struggling, where you have developing nations that are struggling to meet their food needs, there is likely to be a very sharp decrease in agricultural productivity from even a little bit of warming. So there's this, there are issues of justice and inequality that come into it. But you take New Orleans, that was a very vulnerable population. It was vulnerable because, as you say, it's a city that's already under sea level.
Yeah.
And that means that it was highly vulnerable to a combination of factors which we know are leading to greater flooding. Sea level rise plus more intense hurricanes. And there is evidence that climate change is also increasing the intensity of the strongest storms. Whether or not we're seeing more tropical cyclones or fewer, that's almost irrelevant. There is a debate about that. The impacts overwhelmingly come from the biggest storms, like Katrina, like Sandy. And here you had a very vulnerable situation, a city that's below sea level, and a population that was, a fairly poor population, a large population of poverty, of impoverished people who didn't have the resources to contend with a catastrophic event of that sort.
Yeah. Well, if one good thing came out of Katrina, my dog, I adopted her. She was a rescue after the hurricane. They sent the dogs all over the place. She actually gave birth in New Orleans in a box during the hurricane. and her puppies were saved, and I got her a couple months after that. But is a little bit, yeah, she's great. She lived in New York, she's lived in LA now, she's had quite a life. Is a little of this, though, it's sort of man versus God kind of stuff. Because I think there's a certain amount of people that even if they buy into everything that you've said here, they would say, well, just build bigger levees, right? Build higher walls, build higher levees, and let's see what happens. But that's just not a solution.
Yeah, if we were to keep warming below about 2 degrees Celsius, we're halfway there already. And with another decade or two of business as usual, burning of fossil fuels, we'll cross that threshold of 2 degrees Celsius. It's 3.5 degrees Fahrenheit warming of the planet relative to pre-industrial time. That's the level of warming that most scientists who study the impacts of climate change will tell you where we really start to get into that danger zone, where the changes become so large that they exceed our adaptive capacity. We do have some adaptive capacity. For changes that occur slowly, that we can build infrastructure to deal with. We can adapt to those changes. But when those changes come rapidly, then very quickly they exceed our ability. There's no seawall that we can build to prevent the flooding of the city. There is no change in the cultivars we grow that can adapt to the worsening drought conditions. And one could go on. The events become so extreme and so damaging because of the aggravating effects of climate change that there's simply no way to adapt. The presidential science advisor, John Holdren, I think, characterized it in a very thoughtful way. He said, how we deal with climate change is going to be a combination of 3 different approaches: mitigation, lowering our carbon emissions; adaptation, dealing with the changes that are happening through infrastructure, et cetera; or suffering. And arguably our role is to minimize that last category.
Yeah. All right, well, I'm glad you went there with this because we've been sort of focusing on the American perspective here, but there's obviously a huge global issue here. So, I live in Los Angeles and, we're very green here. So, I can't get plastic bags at Trader Joe's. I have to pay if I get a paper bag even, you're supposed to bring your own bags. So we do these little things and, I sort of think they're nice to do, but in the grand scheme of things, I don't know that we're really doing anything, but I think being aware of it in and of itself is good. But then when we think about the wider world, and there's countries like India and China that are going through their industrial revolutions now. So all the stuff that we used to put out, all the carbon emissions and all that stuff that we used to put out in the 20s and 30s and 40s in massive amounts, they're doing now. And I know that the leaders of the countries they meet and the UN talks about this stuff. And there's sort of a disconnect because it's like, we already got the advantages that burning all that bad shit allows. And it almost feels, like who are we to tell them what to do? So a lot of this has to do with governments now trying to battle back and forth with what they can do, right?
Yeah, no, absolutely. And that's why these negotiations are so tough, right? Because we can point to the developing nations and say, right now, you guys are the major source of any growth in carbon emissions. Mm-hmm. And they can look at us and say exactly what you said. Hey, you guys got your turn. You had 2 centuries of free access to this dirty source of energy that allowed you to grow your economies. Why shouldn't we have our turn? Mm-hmm. And it's a compelling argument if we don't do everything, if the industrial world doesn't do everything that it can, that doesn't do it, that the industrial world doesn't do its share in combating this problem. And that's where the negotiations become so tough. The developing world will say, well, you also need to make reparations. You already did some damage to the climate. We've suffered as a result of it. You should give us some money, basically.
Right.
And that money will help us in our transition away from fossil fuels towards green energy, towards renewable energy. And so those negotiations quickly become very contentious. They're easily politicized. In what's already a very partisan political atmosphere, you can imagine how challenging it has been for the Obama administration to to participate fully in the latest summit, the Paris Climate Summit,
Yeah.
knowing that they're going to see efforts by the Republican Congress to undo everything that they're trying to do. It makes it very tough. In the end, I would say that we have seen some real progress. China and the U.S. did come to a bilateral agreement last year to lower their carbon emissions. The two largest emitters on the planet, us, because of our historical emissions, China, especially because of their dramatically growing emissions. They've now exceeded us in terms of total carbon emissions. We exceed more on exceed them on a per capita basis.
Mm-hmm.
There was this agreement between both China and the U.S. to lower carbon emissions. The U.S. will bring its emissions down over the next decade to 2 decades. China will peak their emissions. Since they're not as far along the curve, just getting them to bring it to a peak is a real accomplishment. And that's where you see a little bit of a disparity, a little bit of a concession to the developing nation versus the industrial nation. And those are the sorts of difficult negotiations that we're going to need, and which are now happening through this process, through Paris, the Paris Summit, where we did see major international progress in combating this problem.
Who actually polices this stuff? I mean, does the UN really have a group of people that go from country to country and test all this and report back? And are there punishments? I mean, when a lot of times we see with the UN on security things, especially. I mean, think about what's going on in Syria. There's a lot of documents signed and condemnations of this and that. It doesn't really mean anything in real terms. Who's actually doing the policing here? Yeah,
it's a great question. And no, these international agreements don't have the force of law. And the IPCC is now sort of recognized that, embraced that. So rather than talking about policing and penalizing countries that don't meet their obligations, they're instead using what you could call a name and shame approach.
Yeah.
Which is those countries that aren't meeting their obligations. The UN will make it known, which countries are and which aren't. And to me, it's sort of like, being the guy, being the family whose lawn is never maintained very well, and you've got all your neighbors and they have beautiful lawns. There's some pressure on you to step up your game, right? And I think the same principle holds here, as most of the world commits to substantial reductions. And in Paris, we got an agreement that basically will take our emissions down about 50%. Not enough to keep us below that dangerous 2 degrees Celsius, 3.5 Fahrenheit warming, but it will get us halfway there. It'll get us on a pathway where we can see down the road the possibility of truly getting to where we need to go.
Yeah.
And the way they did that was really through peer pressure. Once one set of countries makes some commitments, others are looking over their shoulder. They don't want to be the ones who are pilloried.
So basically, shame is our biggest weapon in the tool in the fight against climate change.
It's no different from life, right? It's no different from the way we don't. The main policing of our actions is through sort of an understanding of what sort of behavior is and is not acceptable.
Right, and I guess what's a better option? I mean, are we going to bomb these people into, submitting to the regulations we want? You brought up lawns as an example, and as I said, I'm in Los Angeles. I've only lived here for 3 years, and in the time that I've lived here, I can honestly say I've seen 50%, if not more, of the lawns in the area that I live in. They've all gone drought resistant, so it's a lot of succulents, a lot of rock gardens, there's like a new rubber sort of thing that looks sort of like dirt. Because we are in a massive, massive drought here. So I guess 2 things. 1, how much can we attribute the drought to man-made climate change? And 2, are we going to be able to get out of this? Because, even when I drive up north, I've driven to UC Davis, and all along the road for hours, not only are there no crops, but there are signs. The farmers saying, look what Sacramento, our state capital, has done. They're not giving us the water. They're giving it to you city guys, except we're the ones growing the food. Take a look. It looks like Interstellar around here.
Yeah, that's right. And some of the water is going to natural gas companies, which has been a contentious issue as well. I personally know the governor, Jerry Brown. I've talked with him on a number of occasions. He really gets this problem, and I think he sees it actually as part of his legacy. He wants to make sure that California does what it can to act on this problem, to set an example for the rest of the world. And so I kudos to Jerry Brown. He's doing a lot to help us make progress on this issue. But he is dealing with this, and maybe that's part of it. He is seeing firsthand, as the governor of California, the direct impacts of climate change. And so the first part of your question, yes, there is a connection. There is some debate within the scientific literature about whether the very low rainfall and snowfall amounts over the past several years, whether we can truly attribute that to climate change, because that relates to the pattern of the jet stream. And that's one of the more subtle questions. In fact, we talked about that earlier, how the jet stream is impacted by the warming of the planet. That's still sort of at the cutting edge of the science and saying exactly what impact that'll have. So in my view, the very low amounts of precipitation are actually tied to climate change. I think there are scientists who've made a compelling case that even that piece is tied to climate change. But even if it weren't, water, soil moisture, drought is a product of two things. It's how much water you're getting, either through rainfall or through the melt of snowpack in the Sierra that runs off in the spring, how much you're getting and how much you're losing to evaporation from the ground, from the soils. And one of the simplest relationships in all of atmospheric science is that as you warm the surface, you will get more evaporation. And so even if climate change hasn't impacted the amount that's coming down, it's increased the amount that we're losing and making drought worse because of it. And even this El Nino, a lot of folks were looking to this latest major El Nino event. You look back at the 1997-98 El Nino, and that was a very wet year over a large part of California. So there was this hope that this latest El Nino event would be a soaker.
So it basically just didn't happen, right? We're supposed to be in it right now, is that right?
Yeah, it did not. The El Nino definitely happened. What didn't materialize was the impact that El Nino is supposed to have on rainfall in the western U.S. And it's got some scientists scratching our heads, wondering, for example, if El Nino may no longer be operating the same way it used to be, that it used to. So to those who thought, well, at least we can rely on intermittent El Nino events to give us, to make up for that water deficit, even that's unclear. And so California still finds itself a large part of California. I think most of California, even after some reasonable amounts of rain and snow in the northern half of the state, even after that, California is still in major drought over most of its area.
So related to California, one of the things I hear people say a lot is that we should invest in desalination plants, which basically is taking seawater and getting the salt out of it. It's a little more complex than that, but that's the general idea, and then you can drink that, and this is done all over the world. One of the things you hear against that is that it takes a tremendous amount of energy to do that. So where do you fall on that? Do you think it would be a good use of resources to help us with our water situation, or are we then using too much energy, which is going to cause all sorts of other problems, to make it worthwhile?
It's a great question. It has no simple answer. In the end, it comes down to, can we afford to lose California? The biggest agricultural.
I hope not.
We can't, right? We know that it's literally too big to fail.
Yeah.
We can't lose California as because of its contributions to our agriculture, but also because of just the natural wonders that it's a unique state with that when we think about ourselves as a country, we take pride in the Golden State. And I went to school at UC Berkeley, and I'm tied to the state of California. And so I don't think we're going to decide that we can just give up on California. That means that we will have to find a way to meet the water resource needs that the state of California has, despite the worsening of drought. And that may indeed point towards building major desalination plants. California's lucky in that regard. It's on the Pacific Ocean.
Right.
Other inland states in the West that are suffering similar droughts won't have that available to them. So at least with the, in the case of California, there's this huge amount of water right at your back door. And the only problem is it's salty. But the physics of that is pretty simple. We know how to get rid of salt. We know that when you evaporate salt water, the moisture that evaporates is, loses its salt. It's fresh. And then you condense it, and water beads of water condensation, and that's going to be pure water.
Right.
And so that process, though, as you allude to, is expensive. It's expensive from an energy standpoint. So there's sort of this quandary, right? Too much energy and the burning of fossil fuels got us into this problem in the first place. And problems like this are going to cause us to need to use even more energy. Yeah. It sounds like a vicious cycle.
That sounds like hockey stick kind of stuff, right?
Well, the way out of that vicious cycle is if that energy isn't coming from the burning of fossil fuels, then we can do it. And so once again, it speaks to the need to incentivize clean energy. And here you've got to hand it once again to Jerry Brown. He recognizes that. It would be inconsistent for him to talk about building desalination plants and not talking about finding ways to get energy without burning fossil fuels for this reason. And that's what he's trying to do. He's trying to get us, off fossil fuels and, implement the sorts of, strategies that California is going to need to implement to meet its, water resource needs in a world where, California is even drier than it used to be.
Yeah. All right. So we've talked a lot of science here. Now I want to wrap this up with a little science/science fiction, because I'm a big science fiction guy. And I mentioned Interstellar before. I even liked Waterworld. I like a lot of these dystopian future kind of movies, and in every science fiction TV show now, it's that, I was going to say Americans, but humans have destroyed planet Earth and we have to go to other worlds. Now we know we're trying to do stuff on Mars, and if you watch The Martian, a lot of that was based in actual science, which was nice.
I have to science the hell out of this, right?
Yeah, exactly. So for the science fiction element of this, I mean, as you said before, the Earth was here before humans. It's going to be here after us. I mean, at some point, I get it. You think we can fix some of this and hope that we can fix some of this, but are we going to have to leave? I mean, is that the point of humanity at some level, is we're going to have to just jump planets because we're going to suck the resources out of this one like a cockroach and then just move on to the next one?
Well, it's funny because there is this contingent that firmly believes that the solution to this problem is colonizing another planet. And it's a sort of techno-optimism, an unbridled techno-optimism that I think...
I like that phrase.
Yeah, it's sort of on its face, it's sort of absurd, right? Because what you're saying is we don't have what it takes to figure out how to implement existing technology. Which, we could meet 100% of our projected energy needs from renewables only. And there's a scientist, one of the leading scientists studying this stuff, Mark Jacobson at Stanford, has written a report, a peer-reviewed article about this. The Climate Solutions Project, he's part of that, along with folks like Mark Ruffalo, trying to get that message out. So we don't even have to invent new technology. We simply have to scale up and incentivize existing technology to solve this problem. And so, to me, there's this remarkable, sort of discordance in a certain group of people who think that we don't have the smarts to solve this problem the easy way, but we can, colonize other planets. Somehow we'll be able to do that, even though we don't know of any planet within light years that could possibly be a home to us or other living things, given any existing technology that we have.
That's funny. I never thought of it so specifically, but is there a real split in the science community? People like you that are saying, let's fix it, let's do the best we can here, versus, I guess the people that are trying to get to Mars. In a way, they have a vested interest, not that they want this, but there's some interest in shit getting worse here because then, more resources will go to them. I hate to be that cynical, but, it's sort of how life works.
I think the most enlightened folks in that group, people like Elon Musk, actually get it, right? Because he's all about renewable energy. He's all about acting on climate change. I think he's called it the biggest threat that we face. But he's also all about space, SpaceX, getting to other planets, exploration. A good friend of mine used to be a neighbor of yours. He's now in New York. I think he spends some time out in LA. Bill Nye, the science guy.
I'm working on getting him on the show.
Oh, he'd be wonderful, and he's become a very important sort of advocate for climate, for a sane discussion about climate change. Again, somebody who is all about exploration. He's the president of the Planetary Society that was founded by Carl Sagan, but he also is a major proponent of acting to avert a climate catastrophe. So there doesn't need to be, those people who get it understand that you can be in support of both of these things. Yeah, we have to explore because that's, we've always explored. It's a part of our being, and we have this need to do it, but we have to get our own house in order. We can't assume that we'll find some other planet that we can live on. And where you start to find that sort of discordance is in a certain group of physicists, and I love physicists. I studied physics at UC Berkeley. I went to graduate school in physics, so I'm all about physics. But I have to say that some of my physics colleagues, there's a certain subgroup of the physics community that really is sort of not just techno-optimists, but I'll call them techno-Pollyannas, okay? Because they just have this irrational faith. And it really is faith, right? We're talking about science, but it's
right.
faith that technology can solve any problem. Among them is a world-famous theoretical physicist, Freeman Dyson. And he is a bit of a climate change contrarian. He's often quoted sort of disputing aspects of the science of climate change. And he's all about, these sort of, there's even something called the Dyson sphere, which is this about civilizations that will build huge spherical structures surrounding their sun to absorb all of the radiative energy of their star and use that to drive their. So he is all about, how sci-fi sort of merges with futurism to envision ways that we could, again, sort of innovate our way out of various predicaments. But a lot of that stuff literally is the stuff of sci-fi. So while he's opposed to doing the basic things that we could do right now to help solve this problem, he's all about pursuing extravagant and fanciful, almost sci-fi, high-tech solutions to a problem where there's a much simpler solution.
Right.
And
well,
we have it within our.
Yeah, I think that's a perfect way to wrap this up because it's science fiction, it's faith, it's everything wrapped up, and that's why this is so complex. So I think we should do this again. We'll do it 1 year from today. We'll send you down to Miami to your family. We'll see if you're underwater, and I'll do it from probably the desert of Los Angeles, although hopefully not, and we'll see what happens. How does that sound?
Sounds like a date.
All right, well, I want to thank Dr. Michael E. Mann for joining me today, and you can check out his book, The Hockey Stick and the Climate Wars, and tweet Dr. Mann all your climate denial theories. It's Michael E. Mann with 2 N's, and thanks for watching, and we'll see you next week.